Okay, so today we are going to discuss electric circuits. Just a moment.
Yes.
Any idea about electric circuit?
So I have like a base vague idea. There's a ammeter, a voltmeter, a resistor, and all of that. And there are series circuits, parallel circuits, and all.
Okay. Okay, so in electric circuits, what we are going to study here, constructing and interpreting circuit diagrams, predicting currents and voltage in series and parallel circuits. Okay, we'll study that series, what is series combination, what is parallel combination, describing the behavior of electric circuits and predicting the effects of logic gates, and describing and explaining electrical safety measures. Okay,
Okay.
so these are the topics. Okay, so these are some notations. So wherever you will find this type of note, so that is a junction of conductors. Okay,
Yes.
this one is cell. This plate is bigger, this plate is smaller. So bigger plate is said to be the positive terminal and smaller one is said to be the negative terminal. Okay, and battery is a combination of cells. If you combine two or more than two cells, then it becomes a battery. Okay,
Okay, sir.
and this is your indication of power supply. Got it? This one is switch. This one is switch. In this scenario, it is open switch. If it is connected with the this one wire, so that is called as closed switch. Okay.
Okay, sir.
A is ammeter. Do you know what?
It can hit the current.
Yeah, it can measure the current, and it is always connected with the wire in series.
Okay, sir.
Okay, and it is V for voltmeter. It always measures the voltage and it always connected into the parallel. It is lamp indication. This is resistor, variable resistor. What is variable resistor?
I don't know, sir.
It can vary its resistance. Okay, like we are using rotary switch in our fan to control its
Yes.
speed. So that is nothing but it is rheostat, or you can say it's a variable resistors. Okay,
Okay.
this is called as another indication of this is that one, that is also called variable resistor. This is again an example, thermistor, so fuse. So we'll study all these things. Okay, now one by one we'll study all. So first of all, that is the resistor. So that these are said to be the components of electrical circuits. So first one is resistor. Do you know about the resistor? What is resistor?
Rejects the resistance.
Yeah, it is a property of conductor to resist the flow of current. Okay,
Yes.
it always resists the flow of current, so that property is said to be the resistance, or you can say, and that conductor is said to be the resistors. Okay, these are some visual examples of resistors. Got it?
Yes, sir.
Okay, so how they are being made can be used to control the amount of current flowing around a circuit. A resistor has two terminals so that the current can flow in one and out of the other. They may be made from metal wire, usually an alloy, a mixture of two or more metal with a high resistance, or from carbon. Carbon, like the graphite, lead in pencil, conducts electricity but not as well as most metals. Hence, high resistance resistors tend to be made from graphite. Okay, whenever you want to have higher resistance, then they are to be made with graphite. Okay.
Yes, sir.
Okay, variable resistors, I told you variable resistors, you can vary the resistance. These are
Yes.
fixed resistance, these are having a fixed resistance value. Okay, but
Yes, sir.
variable resistors, like I told you an example of regulator in we are using in our fan. So that regulator is one kind of variable resistor. Okay.
Yes, sir.
Okay. So this one is, you can say it's a figure of variable resistors. Okay, inside your regulator, these things are there. So a variable resistor, the resistance is provided by a track of resistive wires of carbon. The resistance in the circuit depend on the position of the sliding contact. So as we are operating regulator, so what it is doing, it is just making contact with the number of turns. Okay.
Okay, sir.
So its resistance is affected, its resistance is getting changed. So that that resistors is said to be the variable resistors. Okay.
Yes, sir.
Okay, now we just a moment, hold down. Okay, we now will discuss transducers. We may use many different electric circuits to make things happen automatically. For an example, if the temperature falls, we may want a heater to come on automatically. If someone is moving around inside a bank at night, the burglar alarm must sound. So this electronic systems like these depend on devices described as transducers. Okay.
Yes, sir.
So a system might be represented like this. So this is input transducer, then it is circuit, then it is output transducers. Okay.
Yes, sir.
So what is input transducers? That responds to a change. Okay. If there is a change, then it responds, then circuit is operated, and then output transducers is effective. Okay.
Okay, sir.
So an input transducers respond to a change in the environment, for example, a change in light or temperature, and produces a voltage. The electrical circuit to which the input transducer is connected then provides the voltage needed to operate the output transducers. Okay. We use water heaters in our home. So what happens, once the temperature is down to a certain value, then it again operated. Okay.
Yes, sir.
So that is said to be the transducers. Got my point?
Yes, sir.
Okay. So for a burglar alarm system, the input transducers might be a light sensor. So it's a light sensor, and the output transducer could be a bell or flashing light. So once there is a light on that sensor, so that circuit operates, and after operating the circuit, there is a bell. So that bell rings. Got it?
Yes, sir.
Okay. Some resistors are light dependent resistors. That means they will operate only when there is a light. Okay. So these type of resistors are said to be light dependent resistors. Is a type of variable resistors whose resistance depends on the amount of light falling on it. So whatever amount of light falling on it, they will change its own resistance according to the light. Okay.
Yes, sir.
So an LDR is made up of a metal that doesn't normally conduct well. In the dark, an LDR has a high resistance. So if there is a dark, they will not operate. Okay.
Yes, sir. Okay.
So often over 1 mega ohm. So that means in night they have a resistance like 1 mega ohm, and that's a very big resistance. So nearly they don't operate at night. Okay.
Okay, sir.
So light dependent resistors, the interlocking silver fingers are the two terminals. This is your light dependent resistors. This one is light dependent resistors. Once there is a light, they will operate, otherwise they will not operate. Okay.
Yes.
So a light dependent resistor, the interlocking silver fingers are the two terminals through which the current enters and leaves the resistors. In between, yellow colored is the resistive material. This one is resistive material. Okay. And in the this is circuit symbol of LDR, that is light, the arrow one. Arrow is showing the light. Okay.
Yes, sir.
Just a moment.
Yes, sir.
Okay, so you understood what is the meaning of LDR and how it operates.
Yes.
And what about the circuit symbol? Everything
Yes.
understood?
Yes.
Okay. So our light can provide the energy needed to allow a current. So basically they operate whenever there is a light. So light provides the energy needed to allow a current to flow. Shine light on an LDR and its resistance decreases. So whenever there is a light, its resistance decreases and it operates. Okay. So LDR are used in circuits to detect the level of light. So that is basically used for detection of light, whether there is a light or not, and what is the level of light. So for example, in security light that switch on automatically at night, some digital clocks have one fitted. When the room is brightly lit, the display is automatically brightened so that it can be seen against its bright surroundings. Okay. So whenever there is a small light in the room, so they adjust its brightness automatically.
Yes.
Okay.
Yes, sir.
And whenever there is a bright light, so they adjust it accordingly, so their brightness is increased. Now thermistor. Thermistor, as the name also suggests, therm means it is affected by the temperature. Okay.
Yes.
So it is another type of resistor whose resistance depend on its environment. In this case, its resistance depend on its temperature. So the resistance changes by a large amount over a narrow range of temperature. As the temperature changes, they change its resistance. Okay.
Yes, sir.
For some thermistor, the resistance decreases as they are heated. So as their temperature is increasing, their resistance is decreasing. So 20 ohm at 100 degrees centigrade, these thermistors are thus useful for temperature probes. See the discussion of thermistor on page number. Okay, for other thermistors, the resistance increases, like in your AC, thermistors are used. Okay. As your
Yes.
temperature is above the certain range, then it operates automatically. Okay. It allows the circuit to flow the current, and it again switch on the outer unit. Okay.
Yes, sir.
So for other thermistor, the resistance increase over a similar temperature range. These are included in circuits where you want to prevent overheating. So whenever you want to prevent overheating, so that means circuit will cut off at a certain temperature. Okay. If the current flowing is large, component may burn out with a thermistor in the circuit. The resistance increases as the temperature rises and the high current is reduced. So this is this is just a visual display of thermistor. Okay.
Yes.
That is a thermistor, and that is its electrical phenomena. As its temperature rises, as the temperature is rising, its resistance is decreasing, isn't it?
Yes.
At this temperature, resistance was very high. As the temperature is increasing, resistance becomes low, and at this temperature, resistance is not going to be increased. It becomes a constant. Okay.
Yes.
And that is the notation of thermistor. Getting it?
Yes.
Okay. So this is just basically a circuit diagram in which it is a resistor, it is a capacitor. In capacitor, both the plates are equal. Okay.
Yes.
In battery, in cell, both the plates were different length. Okay. But
Okay.
in case of capacitor, they are being shown as parallel and equal plates. Okay. This is switch.
Yes.
This is battery. You can say it is a cell. So a capacitor in a simple circuit, the voltage across the capacitor increases as it charges up. So if we talk about a capacitor, as its charge up, its voltage is increased. Okay. Like we use capacitors in fan. So what they do, as you switch on, that capacitor gets charged and it increases the voltage. Okay. So it is just giving a start to the fan, and after starting, then it is cut off. Okay.
Yes.
So suppose you want the interior light in a car to switch off 20 seconds after the driver has closed the door. Circuit with a capacitor will start to charge up as soon as the door is closed. After 20 seconds, the voltage across the capacitor reaches a certain level which operates the switch to turn off the light. Okay. So after a certain moment, that light will automatically be off. Another one is relay. Okay. Relay is just like a one kind of switch. Okay.
Yes.
So how it works? Relay is a type of switch that works using an electromagnet. Okay. For an example, do you know what is electromagnet?
Yes, like an electronic magnet which attracts, right?
Yeah. So like let us say it is a ferrous metal. Okay. And this is your electromagnet. So what happens? Electromagnet, the property of electromagnet is it behaves like a magnet till the time current is flowing into that conductor. Okay. If no current, then it will not behave like a magnet. Got it? As your for example, your doorbell, as you press the switch, what happens? Doorbell rings,
Yes.
and then automatically cut off. Okay.
Yes.
So what is happening there? There is a hammer. Okay. As you press the button, that hammer get magnetized. Okay.
Right.
And there is a drum. So that hammer strike the drum, as it is a ferrous metal. The drum is a ferrous metal, and this hammer becomes electromagnet, so that hits the hammer. Okay.
Okay, sir.
And as you release the switch, it again goes back. Got it? So
Yes.
that is the task of relay. So relay works on the principle of electromagnet. So the diagram 19.8 shows that when a relay is used, there are two circuits. This one, just will understand it. Yeah, this one. Okay. So this one is your relay. So as you switch on, so what happens? A relay is used to link two circuits together. The relay is composed of a coil and a switch shown in blue dashed box. So like it works on electromagnetism. Okay. So as you switch on this circuit, so current will flow into this circuit after a certain very less time. Okay. It's in milliseconds. As you switch on this one, so that is a principle of mutual induction. So by the mutual induction, that current will also flow into this circuit. Okay.
Yes.
So that is called as relay, and it gives a tick sound once it operates. Okay.
Yes.
So a relay is used to link two circuits together. The relay is composed of a coil and a switch. So that is switch and that is a coil. Okay.
Yes, sir.
So the entire one, this unit, this blue one unit is said to be the relay. Okay.
Yes.
So the electromagnet coil of the relay represented by a rectangle is in one circuit, the switch is in the other circuit. When a current flows through the relay coil in the first circuit, it becomes magnetized. It pulls on the switch in the second circuit, causing it to close and allowing a current to flow in the second circuit as well. The second circuit often involves a large voltage, which would be dangerous. So why relay is used?
I don't know, sir.
Why we are not putting a switch only? Why we are using relay?
Well, in some circumstances it might not work,
No. Like if you are operating on a very high voltage, so what happens once you switch on the circuit?
Turns on. Yeah, turns on. Electricity moves around.
Turns on, but it gives a very high spark also. Okay.
Yes, yes.
And it is very dangerous to operate. So what we do, we just connect a relay before that circuit. Okay. So we switch on the relay. Relay operates at 240 voltage, 230 to 40 voltage, but it switch on the higher voltage circuit. Okay.
Okay, sir.
But it switches on after 10 to 15 seconds or very less second, but you can switch on the relay and you can go out from there. Okay. Then it is a safe distance to operate that circuit. Got it? So that's why relay is being used. So whenever there is a high voltage circuit, so there relay is used. Okay.
Yes.
So it doesn't turn on it doesn't turn on instantly, but it takes some time. let us say 1 second, 2 second, 3 second, 5 seconds. So we can decide it how much time we want. Okay.
Okay, sir.
So that is very important thing. Then whenever there is the second circuit often involves a large voltage. So whenever there is a large voltage, so which would be dangerous for an operator to switch, or which could not be switched by a normal electronic circuit. Okay. So relay is operated at a very low voltage. So we switch on that relay, and that relay will switch on the higher voltage circuit. Okay.
Okay, sir.
So that is the use of relay. As you can see, it's a 240 volt circuit. So we are just switching on this this switch, and it operates the relay, and relay is operating that higher voltage circuit. Okay, it is taking care of that higher voltage circuit. So there is no chance of shock to the operator. Okay.
Yes.
Okay. Another one is diode. Do you know something about diode? What is that?
No, sir.
Okay. So diode is a special kind of conductor. Okay. It's a special kind of conductor. You can say it is a let us take an example. If you are in house and someone is ringing your bell, so it is your choice whether you are going to open the gate or not. Okay.
Yes.
So diode works on the same principle. Means if you want to allow current to flow, then you can place your diode there and you can design it when there is a need of current to flow. Okay.
Oh, yes.
So diode is just like a gate, you can say. So diode is a component that allows electric current to flow in one direction only. That current can't flow in two direction. Okay. So whenever
Yes.
it can be connected in two situations. That is the symbol of diode. Okay.
Yes, sir.
So it is always connected in forward bias. Forward bias means if you connect, this is said to be its P junction, this is said to be connected, this is said to be called as N junction. So the P junction always connected with positive terminal of the battery or positive terminal of the cell, then only it will work, otherwise it will not work. Okay. So
Yes, sir.
current will flow like this. If you connect it differently means that P terminal is connected with negative and N terminal is connected with positive. Sorry, P terminal is connected with negative and N terminal is connected to the positive terminal of the battery, then current will not flow. Okay.
Yes.
So that condition is said to be the reverse bias. This connection is said to be reverse bias, that is said to be the forward bias, and current only flows in forward bias. Okay.
Yes, sir.
So that is the main thing in diode. So diode is a component that allows electric current to flow in one direction only. So its circuit symbol, this is its circuit symbol, I already told you, represents this by showing an arrow to indicate the direction in which current can flow. So this is its arrow direction. So arrow direction means current can flow into this direction only. It can't flow opposite to the arrow. Okay.
Yes.
So the bar shows that current is stopped if it tries to flow in the opposite direction. It can help to think of a diode as being a waterfall in the circuit. Charge can flow over the waterfall, but it can't flow in the opposite direction. Like if you think about a waterfall, water is always flowing from higher to lower height. Okay, it can't flow back.
Yes.
So some diodes give out light when a current flows through them. A diode that does this is called a light emitting diode. You know about LED?
Yes, the LED lights are there.
Yeah, so that is nothing but it is a one kind of diode, and that type of diode is said to be the light emitting diode. Okay,
Yes.
so they are giving light whenever there is a current in that diode, so they produce light. Okay,
Yes. Yes.
so it is diode and it is LED. In this you can see that light is going upward, so that means it is giving light. Okay,
Yes.
diode are useful for converting alternating current into direct current. So diodes are used to convert AC circuit to DC circuit. You know what is AC circuit and
No, sir.
what is AC current and what is DC current?
No, sir.
AC current is your alternating current. Okay,
Yes.
AC is your alternating current. And DC is your direct current. You can see by which point you are charging your laptop. So that point is said to be the AC point. Okay, it has 3 holes, isn't it?
Yes.
This one is earthing, this one is neutral, the black one, and this one is live. Okay,
Yes.
and why it is called as alternating current? Because that is the sign, that is the representation of alternating current. It is changing its direction, isn't it? It's a sinusoidal wave, so that's why it is called as alternating current. And direct current is this one. This one is the direct current. Okay, that means it is not changing its amplitude, and in alternating current it is changing its amplitude at every second. Okay, every moment it is changing its magnitude, but in direct current it is not changing its magnitude. Okay,
Yes.
you are charging your laptop, so the output of your adapter is DC. Okay,
Yes.
you have plugged in your laptop charger here. Okay, so the input of laptop charger is AC, but it is connected to the laptop, so then it is giving DC. So the laptop charger is your converting AC supply to DC supply. Okay, and your mobile charger also, it is connected to the AC switch, then it is converting AC to DC, and then your mobile is charging. Okay,
Yes.
so diodes are useful for converting alternating currents into direct currents. So in every charger diode are used. Okay,
Yes, sir.
and what converts AC current to DC current? That electric device is said to be the rectifier. Okay,
Yes, sir.
so this, just write it down. Rectifier converts AC to DC. Okay, it is AC. You connect rectifier with AC and it changes to DC. The input of rectifier is AC, output of rectifier is DC.
Yes, sir.
Okay,
Yes, sir.
note it down please.
Yes, sir. Yes, sir. I'm done.
So rectification is necessary, for example, in a radio that operates from the main supply. Mains electricity is alternating current, but the radio works using direct current. So there are many circuits which operates on DC current only. So everywhere once there you want to have DC current, rectifiers are used. Okay.
Yes.
So light emitting diodes are familiar in many pieces of electronic equipment. For example, they are used as a small indicator lights that show whether a stereo system or television is on. So you can see small lights are there in your TV. In your remote you have that small LED. Okay.
Yes, sir.
Yeah, so that is some examples of LED. Okay,
Yes, sir.
now that is your turn now to have some questions. Yeah, just do this.
Sir, for the first one is just R, right? The circuit symbol.
Draw a circuit symbol for a resistors. Yeah,
Yeah, it's just R, right? The circle, R circle.
just do it and show me. How you represent it? You have to use symbols.
Yes, sir, like the R symbol.
Yeah, just show me.
So like it's just the type. So can you see?
No, it is blurred because you have chosen blurred background. That's why it is not
This is not
visible.
the background, sir. This is the.
Yeah, your background is blurred. That's why.
Yes, sir, it's just the R, sir. Like the R in the circle. Right, sir?
See, circuit symbol for a resistor. Resistor is that one. Okay.
Yes.
Draw the circuit symbol for a variable resistor.
Yeah, the thing with the arrow.
Yeah, the arrow will be there. Okay, or you can represent it like this arrow. So this is also called variable resistor. What does LDR stands for?
Yeah, it's a type of resistor, right? Type of variable resistor. It's light. I forgot.
Light.
Light displaying resistor, something like that. Light dependent resistor, I think.
Light dependent resistors. Okay.
Yes.
So their resistance depends upon the light and how they are shown in the circuit. LDRs.
Yeah, it's a resistor with the upward arrow. Right, sir, from the up.
Okay. What happens to the resistance of an LDR when light is shown on it?
It starts increasing, right?
Yeah, it operates.
Yes, sir. So the resistance starts increasing, right?
Resistance will decrease.
Okay.
Okay. Draw the circuit symbol for a thermistor. Give one use for a thermistor. Explain why thermistor is suitable for this use.
Well, the thermistor just basically measures the temperature, right?
It doesn't measure the temperature. It works.
Does it regulate the temperature then, sir?
No, it doesn't regulate, but it operates the circuit for a temperature. Okay, as the temperature goes up, the circuit is cut off. Okay, it doesn't allow to increase the temperature. Got it?
Yes.
Okay.
Yes.
Now we'll see combination of resistors. So resistors can be used in two combinations. One is series combination, another one is parallel combinations. Okay.
Yes. Yes.
So series means, let us say, this is actually symbolical representation of resistance. So let us say this is R1 resistance and this is R2 resistance. Okay.
Yes.
This is your battery. So the current flows like this. The same current will flow,
Yes.
isn't it? So I current is starting from here, I is there, I current is here, I current is here. So if the current flow is same, then it is said to be the series combination.
Yes, sir.
Okay, and another combination we can use it, like it is a resistance R1, another resistance is R2. Okay, and this is your battery.
That's parallel, right, sir?
Yeah, so it is said to be the parallel. Why it is parallel? Because current I is being flown from the battery. So at this node, current is divided. Okay, some current will be flowing into this one, that is I1. Let us say it is I2. Again, at this node, this is I2 current, this is I1 current. Again, that will combine together. So that will be I current again. So whatever current is out from the battery or out from the cell, the same current will be received by the cell. Okay.
Yes.
So that thing is, that combination is said to be the parallel combinations. Okay.
Yes.
Okay. Is there any doubt in series and parallel combination?
No, sir.
Okay. If the resistance are in series combination, then the effective resistance is given by adding all the resistance. Okay. So let us say, and the unit of resistance is ohm. Let us say 2 ohm resistance, that one. Another resistance is 3 ohm resistance. Another resistance is 5 ohm resistance. So if someone is asking you what is the total resistance or what is the equivalent resistance, so simply what you are going to do, you just have to check whether it's a series combination or a parallel combination. So if it is a series combination, then the effective resistance will be given by R1 plus R2 plus R3. You just need to add all these resistance. So that becomes 2 plus 3 plus 5. So how much it is? It becomes 10 ohm. So that will be the effective resistance of a circuit. Okay.
Yes.
So that means what? If you want to increase the resistance of the circuit, what you are going to use? You are going to use series combinations. Okay.
Yes.
And what is parallel combination? So this one is an example of series combination. So just remember, in series combination, your current will always be same in all the resistance, but voltages will be different. Okay.
Yes.
So that is an example of this. So let us say this is 10 volt of battery. So there are 10 ohm, 20 ohm and 20 ohm resistance. So current will be same. The total resistance will be how much?
50.
50. So 50 ohm will be the total resistance. Okay. But voltage current will be same in all the resistance, but voltage will be divided. Okay,
Yes.
and that is a parallel combination. Okay, so in parallel combination, your effective resistance would be given by 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on. If there are 4 resistance in parallel, so you will add it accordingly. Okay.
Yes, sir.
Okay, like they have given here 3 resistances 5, 10 and 25. So what will be the effective resistance? 1 by 5, 1 by 10, 1 by 25. Okay. 50 will be the LCM, so that will be 10 plus 5 plus 2. How much it is? 17 by 50. So what will be R? R will be 50 by 17 ohm. So it is approximately 3 ohm. Okay.
Okay.
So you can see here that in a parallel combination, your resistance, the effective resistance is decreasing. So if you want to have low resistance, then you must use parallel combination. Okay,
Yes. Yes.
got my point?
Yes.
Okay, and how you are going to find it, the current? This one. So current will be drawn. Do you know Ohm's law? V is equal to IR. So if someone is asking you how much current is being flown from the battery,
Voltage by resistance.
yeah, so voltage is 5 volt
Yes.
and the resistance is 50 by 17. Okay, so current will be 5 into 17 divided by 50, so it will be 1.7 ampere. Okay,
Yes.
so now how you are going to find how much current is being flown into this resistance, in this resistance and in this resistance? Current will be divided. Why it will be divided? Because it's a parallel combination. Okay, so let us think about this first one. So in first one, what will be the voltage? Voltage remains same.
Yes.
So
Right.
so V is equal to I1 R1, let us say. So voltage remains same.
Yes.
So voltage will be 5 volt. I we need to find, and what is R? R is 5 ohm. So what will be I1? I1 will be 1 ampere. Okay.
Yes.
If you want to find the current into this second one, that is of,
Yeah, 0.5 times 5. Yeah.
okay,
Yes.
got it? How to find
Yes. Yeah.
current and voltage? So in parallel combination, voltage will be same, and in series combination, current will be same. Okay,
Yes.
is there any doubt?
No, sir.
Okay, because we directly going to solve some questions. In parallel also I told you, name the following electrical components. Yeah, just answer these questions.
This is LDR, right, sir?
Yeah, it stores energy in an electrical circuit. What do we say it?
Is it like the voltmeter or something like that?
Capacitor, yeah.
Okay. Yeah, and then this thermostat, something like that. Thermostat.
Yes.
Thermostat and also outlet switch. Yeah, is it this
Relay.
relay? Yes, relay.
Okay, fifth.
Input transducer. So what do you mean by this input transducer?
What component could be used as an input transducer for a fire alarm circuit? So for a fire alarm circuit, you can say it's a light. Okay.
Okay. Wait, so what's a transducer again?
Transducer means like a fire alarm. Okay. In daytime, uh, what is fire alarm circuit? As there is a smoke, the bell rings. Okay. So
Yes.
smoke will be the input transducer.
Yes.
As the smoke is there, so there are smoke detectors.
Yes, sir.
And what will be the output for that? Output will be the siren.
Yes.
Okay. So input is the smoke, output is the siren. As smoke is detected, siren will be blown.
Sir, but doesn't this a component, like the component which could be used?
What component could be used as an input transducer for a fire alarm circuit? Explain your choice. So that may be some kind of diode. Okay.
Okay, sir.
That will detect smoke. That is a diode. What is the combined resistance of two 20 ohm resistors connected in series?
40 ohm.
40 ohm, yeah, right. Very good. Three resistors are connected in series with a battery as shown in figure 19.13. Resistor A has the greatest resistance of the three. Current through A is 1.4 ampere. What could you say about the current through B and C? Just answer this question. It's a very simple one. How much current will be there in B and C?
Yeah, correct is the same, right, sir? So 1.4.
Current will be same as they are connected in series. Okay.
Yes. Yes, sir.
And what is the combined resistance of three 30 ohm resistors connected in series?
Yeah, 90.
90. Very good. So in series circuits, voltage are divided, so the voltages can be summed up. Okay.
Yes.
So in festive lights, you can see that they are connected in series, isn't it?
Yes, sir.
So like if you are connecting like 200 of LEDs in series, what will happen? 240 volt will be divided in each LEDs.
Yes, sir.
So that will be very low voltage consumed by each LED.
Yes, sir.
Okay. So the mains voltage shared out between them. The disadvantage of this is that now what happens if one of the LED is damaged?
Yeah, then doesn't the voltage just increase for the others?
Yeah. So, no. If there is a fault with one LED, like you have connected these LED, like one LED, two LED, third LED, fourth, fifth, sixth. Okay, now this one is faulty. So what will happen? That will not pass the current.
Okay.
Okay, so they will not be glowing. So that is the main disadvantage of the series combination. Okay.
No, so it will all be power off. Like nothing will have power.
Yeah. Got my point?
Yes.
Okay. Just do this example 1.
Yes, sir. So the resistance is 15 ohm.
Okay.
Yes, sir. 1 second. Yeah. So 12 by 15. So like the current is 12 by 15, right?
Yeah.
Yeah. And then
Now you need
the
to
potential
find,
difference is basically the voltage, right, sir? So 12.
yes, but as they are connected in series, so voltage difference will be different. Voltage will be
Yes.
divided. So how much will be
Okay.
the
So then what's the
voltage?
potential difference then, sir?
Huh?
Then what's the potential difference, sir?
Potential difference is the voltage.
Yes, sir.
So as they are of 5 ohm resistors, they are of equal resistors, they are connected in series. Okay, that is 5 ohm, and they are connected with 12 volt of battery. So
Okay,
the
12 by 15 times 5.
so current is,
Okay, so then 12 by 15 times 5, right, sir?
yeah. So the voltage is I into R. So I is, so V1. V1 will be I into R1.
Yes.
Okay. So I is 12 by 15, R is 5. So that will be 4 volt. Okay.
Yes.
As they are of the same 5 ohm resistance, so 4 volt will be dropped among each resistance. Got it?
Yes. Yes.
So in series combination, voltage is divided. Okay, that is the calculation. First of all, you need to draw a neat diagram like this. Okay.
Yes.
Then you have to add resistors. It becomes 15 ohm, the entire resistance. Find the current and then PD. PD across the.
Yes.
Okay. Similarly, you can find out the current and resistance in parallel combinations. So these are worked. Example 2 is the homework. Just write it down. That example 2 is your homework. Okay. Write it in
Yes.
your notebook. Example 2 is your homework. And there are some questions. It is better to do it as a homework. If there is any doubt, we'll do it in the next class. Okay.
Okay. Yes.
So up to here it is finished. How much is left? Potential divider, electronic circuits, transistors, practical switching circuits, okay, light sensor circuits. Okay, no issues. We'll do it in the next session. Next session is at Thursday. Thursday.
Yes.
Okay then. Aryan,
Okay.
bye bye.
Yes. Bye.
See you.